Hello, year 7, Mr. Allen here, and today we're going to start our review week, like I told you guys last class, okay? Uh, we are doing this review week. We're going to review units 1, 2, 3. Actually, just a piece of the 3 and just a piece from the 4, from the unit 4, 2, because our test is coming, okay? Test season is coming, so please study and let's focus on this review. You guys do great to finish the semester, okay? So, first of all, let's think about everything that we study in this unit one, okay? So, what are the three main important topics that we study in our unit one? We study factors and multiples, square and square roots, and exponents. So you guys see that this one gonna be really simple. Mister, what about number pattern? Relax, we're not gonna need number pattern anymore. Okay, you already have almost we already have almost 4 units to study for only one check, so don't need to worry about number pattern. I think that you already studied that a lot. Not gonna be necessary. Nice. So what do I should know? What should I know about each one of those topics? About the first one, factors and multiples. I must know the divisibility rules, prime number, composite number, GCF, and LCM. Mister, divisibility rules, they are a must. No, they aren't a must, but it will help you a lot if you use the divisibility rules. Mainly when you're trying to find the factors of a number, okay? And you guys see how everything's related. You guys realize that the those topics that we study now are helping us in unit 4, while studying fractions. So that's why is everything connected. It's always going to help you if you can handle all the topics nice. Okay, so first of all, prime numbers. Those are really important to know. A number that's divided only by one in itself. And what is a composite number? Everything that's not a prime number. Okay, but then I will explain that with more details. Relax in the next slide. Okay? GCF and LCM. What should I know about GCF and LCM? Guys, if you know what is a factor, if you know what is a multiple, if you know what I mean greatest, and if you know what mean least, we can calculate both of them, and I will show you guys how to do it. Okay? So, what I must know about square and square root? I just must know about how to write that thing. How is the symbols here? The symbol, how the symbols are used. Each one is that, and each one is that. Each one is the square, each one is the square root. Okay? And if I go to the next one, exponents. That line here is one of the most important lines of this slide. Okay? Because 5 to the power of 3 is different. That's a different sign from what? From 5 times 3. And even everybody knows that even after I repeat that like 1,000 times, I still have people that confuses it. Okay, so relax. That's the first contact that I have with exponents, but I want you guys to be really careful while you're solving those things here. Nice. And what else I must know? I must know about exponent, exponent, and standard form, and the parts of my exponent. Okay, everything here I'll talk a little bit more, and I will go an example. Nice. So let's go to the first one. Okay, so factors and multiples, okay? How can I find out the factors of 18 and how can I find out who are the multiples for 18, okay? So first, what are factors? Factors are a number that you multiply and you get the number that you want here. So parts of the 18. What two numbers that I multiplied and I got 18 or what three numbers, four numbers? So, mister, I have no idea where to start. So let's start from the basics. What's the first number that I should try to multiply? There is that I should try. 1. There is any number that 1 times something is equals to 18? Yes, I know that there is. I know that if I do 1 times 18, I will have 18. So what is the second number that I should try? 2. So 2. There is any number that 2 times something is a multiple from 2 times something is equals to 18? Yes, 2 times 9. So I know that 2 is what? 2 is a is it's one divisor from 18. So that's why we apply the divisibility rules. Because 2 and 18 in that case are easy to know. But I already know that 2 gonna be in this list. Why? Because I know that 18 is a not is an even number. Okay? So 3. Do I have 3 as a factor from do I have 3 as a factor for 18? Yes, because I know that 3 times something is equals to 18. And using my divisibility rules, how can I show that? I know that 1 plus 8 is equals to 9. And 9 is in the times table of the 3. Yes. So that's how I can apply the divisibility rules. So I can do the same thing for the 4, for the 5. And again, 4 times something is equals to 18. No, I don't have any number in the times table of 4 that's going to be equals to 18. Remember that here I'm talking about only whole numbers, right? So, Mister, but how am I sure that I have my complete answer here? I have everything here, all the numbers that I need. You can do the multiplication. So I know that 1 times something. So both of the numbers going to be equals to what? Going to be equals to my, going to be factors. Nice? And 2 times something. So both of those numbers, they're going to be factors. In the same way that 3 times something, both of those numbers are going to be factors. Now, if I try 4 is a factor. No. 5 is a factor. No. And 6 is right here. So you know that you conclude that you don't need to do all your way back here, try to redo that again. Or you can use the one way that I told you. You can use the rainbow rule. They always gonna match when you try to do that. Okay? So what about the multiples of a number? The multiples of a numbers is nothing else more than the times table of the number. So who gonna be the multiples of 18? The multiples of 18 gonna start from 18 times 1. So the multiples from 18, 18 times 1, then 18 times 2, then 18 times 3, then 18 times 4. Okay, it's nothing else more than the times table of a number. Nice? So another example here with my 11, and you guys see that everything that I did here in the with the 18, I just redid here with the 11. Okay. So if I keep trying here to find 2 times something is equal to 11, 3 times something is equal to 11, and going on, I will never find that number. The same way that here the first one is 11 times 1, 11 times 2, 11 times 3, 11 times 4, and keep going. Nice. So let's go to this example that I find. Ronald and Tim both did their laundry today. Ronald does laundry every 6 days and Tim does laundry every 9 days. How many days will it be until Ronald and Tim both do laundry on the same day again? Nice. So guys, try to do that problem by yourself, okay? And try to do your problem by yourself. Then I'm gonna do that with you. Then I'm gonna do that with you. Okay, so stop. Let's go. So, first of all, what do I know? I know that they both did their laundry together in the first day, right? So they met at the day zero, they meet at the day zero to do their laundries. So nice. So that was the first time. And I want to know when they're gonna meet again. So, for example, Ronald, he do his laundry every 6 days. So he's gonna do on day zero, on day six. What's the next day? Day six. Then what is the next day? Day 12. The next day, day 18. The next day, day 24. And going on, and then goes on. And T gonna do the same thing, but he's gonna do 0, 9, 18, 27, 36, 45. So what those things look like? They look like the timetable from the 6 and the timetable from the 9. Okay? So what I want to know, I want to know when they're going to be the same. So when they're going to meet again. Nice. So I know that they did the laundry together in the day zero, and then they're going to do the laundry together in the day 18. And then if I keep going, 36, and then going on. But do I want to know all of those days? 0, 18, 36. I know that they're going to meet again on the day 18 because I just want to know when going to be the next one. I don't want to know when they're gonna keep doing that forever and ever and ever. Okay? Because someday they're gonna meet eventually, and I can keep going with that list like forever. Okay? And what I just calculate here, I just calculate who was had the list of the multiples of the 6 and the multiples from the 9. The common ones, the multiples that represent Ronald and Tim, so the common multiples. And I want to know which one going to be the least one. So the least one of my list going to be who? Going to be my 18. Mister, and what about 0? 0 doesn't count. Okay? When I'm talking about LCM, the 0 never going to count. Cool? So let's go to the next topic. It's okay. So square root and square. I want you guys to pay a lot of attention to those two words, okay? And what's the difference between them? So what if I want to calculate the square root of 36, how am I gonna do it? I know that's gonna be I'm looking for what the square root gonna be that sign that look like a V and you put and you draw a like here. Okay, so the square root of 36, the square root of 36 is equals to 6. Why? Because 6 squared is equals to 36, or 6 times itself is equals to 36. And what is the square of 36? The square of 36, it will be equals to 1,188. Why? Because when I'm squaring a number, I'm multiplying the number times itself. Okay, so pay attention to the difference of those two ones, square root and square. Cool. I'm gonna show you guys an example that I think that will help you a lot. When you have a graphic thing, I think that helps. So if I count how many, first of all, here I have a square, and if I count how many squares that I have in that figure, I know that I will have 30, 25, correct? And think with me, the big square is called a square number. Why? Because I can do a square with 25 small squares. Okay? And what's going to be the square root of my square? Going to be the bottom. Think about root from the English. No, don't think about mathematics. Think about English, the language itself. So what is the root, the bottom of my square? Is 5. So the number when I'm squaring a number. Okay, so if I'm squaring 5, what I'm doing, I want to square with 5 centimeters as a length, or 5 units as a length. And when I want to calculate the square root of 25, it means that I have a square that is 25, and I want to know what is the bottom of it. Okay, so do you guys understand the difference? Nice. A hint: square root always going to be a smaller number. Nice? At least for now, year 7. Okay? So square root are going to be least than the square. So next, and let's move to our next topic. Exponent. Guys, that one I cannot complicate that anyhow. So I know that I have what I need to know. I need to know the parts of my exponent. I know that I have a base. I know that I have an exponent. That's the small number that I have at the top. And that number must be small in the top right. Okay? Always. Why must be small in the top right? Because if not, I'm going to write 24. And I don't want to write 24. I want to write 2 to the power of 4. So pay attention on that. Okay? And think about the 3 ways that I have how to write a number. I can write my number in the exponent form, and I can write that in the expanded form and the standard form. Okay? So the exponent with exponent, the name say by itself. Extended. Expanded means what? When you extend, when you open a number. Nice? And standard. Standard from English means what? Means normal. The proper way how to write a number. So what is the proper way to write 2 to the power of 5? It's 32, because when you do 2 times 2 times 2 times 2 times 2 is equals to 32. And guys, just more 2 comments that when I'm talking about perfect cube and perfect square, that are 2 exponents that has a special name here. I'm saying that I'm cubing a number. When my exponent equals 3, I'm saying that I'm cubing a number. And my exponent equals 2, I'm squaring a number, like when I was talking about squares and square roots. Okay? So that's it. There is no way how we can complicate the unit 1. In a nutshell, it's everything is only this. Okay, so do not worry about number patterns. Like I told you guys at the beginning of the video, that part I'm not gonna cover that on the test. I think that's enough for this trimester about number patterns. Check Google Classroom for activities and see you guys after. Bye bye.